There are many around us who think that we're in the midst of the fourth industrial revolution. There was steam, electricity, computing, and now artificial intelligence. And there are a lot of interesting angles that we could explore about artificial intelligence. Angles from a social standpoint, ethical, moral, socioeconomic, and even existential. There are some of our greatest minds of the last decade who have existential concerns about artificial intelligence. People like Elon Musk, the late Stephen Hawking, and Bill Gates. And I think this quote from the 1800s from a very famous novel is a little interesting given our present-day situation. Who's the creator and who's the master? But those are interesting topics that we can talk about later during our cocktail hour. And today we're really going to talk about the artificial intelligence of here and now, the one that we as technology lawyers have to deal with in the present, because our companies and the people and the clients who we serve are in the process of building, buying, and using artificial intelligence. So let's break it down a little bit and talk first about what we mean by artificial intelligence and the different terms that you hear around its use. Artificial intelligence at the highest level relies on big data for its fuel. And it takes into account the big data and begins to learn from that data much in the same way that a child learns. As we move through different levels of artificial intelligence, we get to machine learning, which really involves the machines determining patterns, rules, and correlations that they use to try to assemble data sets and to try to make sense of this big data. When we talk about deep learning, we move into an area of the big data going into a machine that's perhaps been programmed with some algorithms, and the algorithms are then trying to establish these patterns and rules and correlations. They might be doing it on the basis of image recognition, or it might be done on the basis of natural language processing. But in any event, the machine is doing a deeper level of learning. And the more data you feed, the more it learns and the more it changes itself after processing that data. Within deep learning, we have two types, supervised learning and unsupervised learning. So let's talk about those for a minute. So this is how supervised machine learning works. You start out by programming the machine with an algorithm. You give it categorization tools. You then feed data into the machine, and the data then is able to start categorizing that data and recognizing differences between it based on the programming or the algorithm that you did in step one. So you start feeding it cat pictures, and as it assembles that data, it's eventually able to determine that there are some cats and there are some not cats. Unsupervised machine learning involves not pre-programming the machine with an algorithm, but feeding the machine the data and letting the machine make its own patterns, correlations, determinations, and ultimately it makes those into algorithms that the machine then uses to categorize the data. And so once again, it starts saying, these things look alike. I'm going to start recognizing these as cats, and these things don't look like cats, so I'm going to put them into a different group. And oftentimes we're talking about probabilities around these items. So it's not that it's actually labeling them, although it could become smart enough to do that, but it's assigning probabilities and saying on this data point, this is similar enough to a cat where I'm going to put it up in this group with this similarity. So that's supervised and unsupervised learning, and that's AI. But you might say, you know, what's really different here? We've been doing this for quite a while. We've been using software programs, and we've been using algorithms. So what's the big difference? The big difference is really the combination of the big data and the computing power that we now have. And it really is creating a fundamental difference in the way that we are using computing power to do our business needs. So it's fundamentally different. It's also rapidly growing, and that presents a lot of challenges for us as technology lawyers. I think these stats represent some of the growth factors that we look at. So for example, 46% of CIOs are planning on implementing AI sometime in the near future, but currently only 4% have actually done it. Forbes is showing that there's a 34% compound growth rate in the last 5 years around machine learning patents. And spending on AI, according to IDC, is going to increase to $58 billion by the year 2021, not very far away. So this is coming at us extremely rapidly, and we need to be prepared as technology lawyers for how we're going to deal with this. So how do we stay ahead of this? How are we going to help our clients in their choices of building, buying, and using AI, and in the contracts that they need to put together? Let's think for a minute about the current legal constructs that we have. Are these going to be useful to us? Let's examine this for a little bit and see if they are. I think one of the things that's going to be very clear is the courts are going to be helping us with AI conflicts and principles far sooner than our legislatures are. And that doesn't mean that nothing's being done at all. We've seen in a number of states that some of them are already passing autonomous vehicle laws, as an example. We've seen with the FDA has gotten involved in approving one of the first artificial intelligence diagnostic tools that relies completely on the software and the algorithm and does not rely on a health professional or a doctor to make a diagnosis. And this has become a very effective tool. It was something that was granted to a company called IDX, and it's being used to diagnose retinopathy. And of course, Congress has gotten involved as well, and in May of last year, Congress put together the Artificial Intelligence Congressional Caucus. And that caucus is intended to both look at policy considerations around artificial intelligence, as well as to promote growth and innovation in this area and take all of those matters into consideration. So there's not been no response, but as we continue to look at some of our current legal constructs, I think we'll find many of them are lacking to help us with artificial intelligence. So let's talk for a minute about patents and IP law, for example. With patents, people invent things, not companies and not things. People invent things. And while the Patent Office has said that patents won't be negated by the manner in which the invention was made, an inventor is still an individual, according to our US patent laws. What about in the area of copyrights? Well, we have a similar issue with copyright law. The Copyright Office has said that it will not register works produced by a machine or mere mechanical process that operates randomly or automatically without any creative input or intervention by a human. This principle was recently, I find, rather humorously put to the test in a famous case that you all may have heard of called the monkey selfie case. This is Naruto. David Slater was a wildlife photographer who went out into Indonesia in 2011, set up his camera in the midst of some macaque monkeys, and a particularly precocious one came up and played with the camera, and the result is the monkey selfies. I think many of you have heard of this case. David realized that he had gold, and he went back and published it in a book, but he was very upfront that David had not snapped these pictures. In fact, Naruto had come up and played with the camera and taken the pictures of himself. Well, PETA got involved in this, the People for Ethical Treatment of Animals, and decided to become a friend of Naruto and bring an action on his behalf, asserting copyright infringement of Naruto's interests. This case was recently decided on April 23rd in the Ninth Circuit, and the Ninth Circuit affirmed the lower court's decision that it was dismissed because a monkey is not able to assert copyright infringement, nor are any other animals nor nature, only humans. So if a sentient being like this guy can't hold a copyright interest, I think it stands to reason that machines are not going to be able to hold copyright interests either. So clearly we have a gap in our IP laws They are not set up for the furtherance of artificial intelligence. And a lot of our other areas lack a framework and suitable principles for us to apply to. If we think about the areas of tort law, the concepts in tort law are things like reasonableness and intent and scienter. These are all concepts that apply to humans, not to machines, not to machine actions. Although we do have an interesting case in this area as well that came out of the Ashley Madison data breach, where Ashley Madison had deployed some computer bots on its service, and these bots simulated, not surprisingly, females. And so when male guests signed onto the service, they began having interactions with what they thought were actual humans when in fact they were bots. And the bots were quite successful at getting some of the male guests to sign up for additional services. Well, this all came out around the Ashley Madison data breach, and Ashley Madison was found to be using fraudulent and deceptive behavior by using bots to impersonate humans. And we might laugh about that, but actually if we think about how many businesses are using chatbots today, it might be an area where we need to think about making a disclosure that you're not actually interacting with a human, you're interacting with a machine. So that's tort law. What about agency law? Can we use those principles in the context of artificial intelligence? Well, agency law is typically a relationship between a principal and an agent. And typically there is a scope that the agent has. Well, when artificial intelligence and neural networks start evolving and making decisions on their own, at what point might they have evolved past the scope that the principal had given to the agent? What about liability? How are we going to think about liability when we're talking about artificial intelligence in contracts and in our use? On the one hand, we tend to treat software as a service. We have warranties and you have remedies that are made on the basis of a breach of warranty. Products, we have a whole other area of law that's evolved, product liability law. Is artificial intelligence more like a service or more like a product? And what happens when you combine artificial intelligence with actual tangible products? What do you have then? Like the things that Linda was speaking about earlier today with Internet of Things. And then what about strict liability? Is that possibly going to be a framework that we can look to? You know, today when people keep dangerous animals in on their property and those animals get free, they are strictly liable for any damage or harm that those animals cause. Might that be a way for us to think about artificial intelligence? This is all yet to be determined. So we've got some interesting problems that we're going to need to help work our clients through. Now, I think these examples show that our current legal constructs don't really provide a good framework or good principles for us to handle artificial intelligence yet. Let's think for a minute about some of our regulatory frameworks and some of the challenges that artificial intelligence will have in that area. One of the hallmarks around our regulatory frameworks is that they exist to provide transparency, control, and auditability. Those are three words that are a big problem for artificial intelligence. We have a lot of artificial intelligence that's being developed today that's doing fantastic things, but the engineers who are developing it are not able to tell us why certain decisions are being made or why certain commands are being executed. In a recent MIT Technology Review article about this topic, there was a discussion about NVIDIA's car test in New Jersey. The engineers are doing an autonomous vehicle test. They built the car, they created the sensors, and thousands of pieces of information come into the sensors, get processed, and then get translated into commands for the car. In addition, they taught the car to drive by having it observe how humans drive. I hope it wasn't based on how my sons drive, but it watched how humans drive, and the car learned and it drives. One of the problems is that the engineers are not able to explain how the car is making the decisions that it makes and how it governs the operations in the car. And problems about not being able to explain AI become even more apparent when we talk about places where understanding the theory behind it can actually really help us. For example, in Mount Sinai Hospital, they did an AI program called Deep Patient. They took 700,000 patient records, they ran them through an algorithm that they created, and Deep Patient started being able to diagnose certain diseases. One of the things that it became very proficient at diagnosing was certain psychiatric disorders, and schizophrenia in particular. But the engineers who put this together to this day cannot explain why Deep Patient is so much better at this than humans are. And if they could get those explanations and those understandings, they might be able to share that very important information in other applications. Clearly, we're going to have artificial intelligence that is capable of meeting these regulatory requirements, but really meeting our social norms and our social expectations around why actions are being taken, and particularly when those actions affect us. What's the basis of the decision, and how do you explain it? Our government is aware of this, and actually the DARPA, the Defense Advanced Research Projects Agency, is working on something called explainable AI. What they are doing is teaching their machine not only to get smarter and to make decisions, but to be able to explain the basis for those decisions as it processes all of this big data. And so, for example, the DARPA AI project can analyze email groups and say, for example, this group of emails looks like it could be coming from a terrorist organization, whereas this other group does not, and it will assign probabilities to it. But it also is able to tell the engineers, I made that decision on the basis of these terms and these patterns and these factors. And artificial intelligence and deep learning has so many layers and so many neurons to it, we're never going to understand each and every decision it makes. But there is hope that we can teach it to share those explanations with us. And that's going to be important for regulatory compliance, and as I said, just for our basic social norms and expectations. So, our laws and regulations are going to lag. Our courts are going to have to get involved in helping us work through some of these difficult issues. But right now, you and I have problems. We've got to figure this out now because we've got clients who are building, buying, and using AI, and we have to help them in the contracting process. And we're lacking principles and frameworks to do that. So what are we going to do? In the short term, we're going to have to address a lot of the issues that we just talked about through contracts and good contract language and contract principles. So let's talk about some of those principles. All right, first, I think you've heard this before today, but it merits repeating. Think about machines, not humans. You need to pull out your contracts and read them line for line and think about, does this principle still work when I think about the machine being an actor versus a human being an actor? You need to look at the definitions that you use. Marina talked earlier about users. That's a key example. Many of our technology agreements have a concept of user. Does your definition allow for a machine user? Because you could have bots that enter into your system. Your clients might need to start using bots, and those bots might actually become users of some of the services and software that you have. So take a look at your agreements and think about them in terms of machines, not humans. Now, write clear intellectual property, license, and ownership rules. This one seems obvious, and we're not saying throw out the intellectual property rules of copyright and patent, but they may not cover all the developments that happens with neural learning, deep learning, neural networks, and algorithms that a machine is writing. So you're going to have to write very clear rules in your contracts that cover who gets the benefit of owning that, who gets the benefit of using it, and what are going to be the future use rules around it as it continues to evolve. We heard a lot today about privacy and concerns around that, and clearly we're going to have to incorporate privacy by design and by default into our artificial intelligence. These principles have to be considered. We already have laws where we have to comply with this. GDPR, for example, which we heard about earlier today, has new regulations around profiling and data subjects having a right to understand the basis on which decisions about them are being made. We have this in the US right now with the Equal Credit Opportunity Act, where decisions about individuals have to be made on an explainable basis. So this isn't new, but we're going to have to teach our artificial intelligence to respect these principles and to incorporate them into its learning. You want to mandate transparency. We need to move toward explainable AI for the things that we talked about, the transparency, control, and auditability. So as you're looking at AI solutions to buy, you're going to want to talk to the developer to understand, is there a means of transparency? Can I explain this AI? Will I have a basis for understanding the decisions that are being made? And in the short run, this might, for example, lead to you're only using supervised learning versus unsupervised learning AI. Because at least with supervised learning, there's some initial programming of an algorithm and there's some categorization of the data sets that are used. It's a little more transparent and a little more explainable than unsupervised AI. Here we go, the theme for the day. Recognize that with big data comes big responsibility for cybersecurity. You've got thousands of lines of code being written by a machine. You've got neural networks being formed. And all of this increases the potential for cyber attacks at any point in time. So what you might need to think about is writing in requirements with your AI provider that allow you to stop the process and do some vulnerability testing and assessments on the AI. So you're going to have to incorporate places and times when you can push the pause button and take a look at what's being developed and stress test it. Determine contractual liability. This is obviously going to be the biggest challenge that we all have in the room here. We don't have good legal constructs at this moment for determining what liability should look like, but we're going to have to spend some time thinking about this, thinking about all of the things that can go wrong, and in the short term trying to allocate the responsibility as best we can between the builder, the buyer, and the user. Address the human impact. So if you are helping your clients in a business to implement AI, you do need to stop and think about what will the human impact be. For example, in Europe, we have many laws that protect employees, and if the implementation of AI is going to make their jobs redundant, that might trigger requirements under what's known as the Acquired Rights Directive laws. Here in the US, if you deploy AI and it affects jobs at a facility, might you have a requirement to give a WARN Act? You're going to have to think about these issues in the deployment of AI. And then, I submit, and I'm not sure this is easy to do, but we have to talk about it and think about it with our clients, that you really need to plan for the end, or at least a pause. Like we just talked about with being able to stop the program and test it and stress test it for security, you're going to have to think about the need to do that and how will your business continue to operate while you're looking at what the AI has created. So if you have to put something on hold, how are you going to continue doing your business until you're able to resume that AI program? So AI is here, it's clear, and it's exciting, and it's going to take us in new places. This really is an exciting time to be a technology lawyer. And I think that we're in a position to both observe and influence the fourth industrial revolution. Thank you.